The next speaker of the session is Dr. Zhongkai Zhao, and Dr. Zhao receives his PhD from in agronomy and bioengineering from the University of Liège, Belgium, in 2019. He's currently a lecturer at the College of Life Science and Technology at the Xinyang University in China. His laboratory engages in research and education in the fields of agricultural products processing and utilization, especially focusing on physiochemical, functional, and nutritional properties of food components. And the title of this presentation today is the combination of high hydrostatic pressure and supplement effects, gelation properties of sweet potato protein. Thank you, Dr. Zhao.
Hello everyone, my name is Zhongkai Zhao. I am come from the College of Life Science and Technology, the Xinjiang University in China. It's my pleasure can be introduced the part of my previous work focused on the sweet potato procession. Today my topic is about the combination of high hydrostatic pressure and the supplement effects the gelation properties of sweet potato protein. As we all know that the China has the highest quantity of sweet potato, which accounted for more than 60 and 90% of total production in the world and Asia. During the sweet potato procession for starch, there are also many aggregates produced, such as the peels, residues, and the wastewater. For the wastewater, there are many waste-soluble protein in it, which accounts for about 30% of total dry matters in effluent. Therefore, recycling the sweet potato protein element from starch processing wastewater both have environmental and economic concerns. The ability of protein to form material is important in food industry. While the protein is accessible by the processing method such as the heat treatment or the APCT treatment, and the different supplements, for example, the MTGs, sulfate-containing amino acids, and salts, are the most successfully commercialized non-thermal procession. The HHP effect on non-current linkages, and it has been shown the positive effect on unfolding aggregation and gelation for different vegetable protein elements. Previous our work, Figure 3 showed that the HHP treatment has a positive effect for the induce the cross-linking between SPP molecules under non-reducing conditions, while for the reducing conditions there are no aggregates formed. That is suggested that the HHP used the cross-linking by the disulfide bond linkage. And another experiment showed that also under reducing and reducing conditions, they are all observed the high molecular SPP aggregates. And it suggests that compared to the disulfide bond and the enzyme-induced the cross-linking are more stronger, and maybe the mechanism is different. According to the texture analysis, we can see HHP and the MTG's treatment improved the texture indicators. Our findings prove that the HHP and MTGs both could induce the covalent cross-linking of SPP by by the formation of disulfide bond of the gamma-glutamine lysine isopeptide bond respectively. Another experiment showed that the sulfate-containing amino acid and the hydrostatic pressure both can be used to improve the gelation properties of SPP. With the different addition of L-cysteine or L-cysteine, you can see from the texture factors for the hardness, springiness, and chewiness are improved by the different amount of sulfate amino acid. The APCT mechanism may come from the sulfate group supply. And according to previous this works, as undeveloped protein resources, both antigens and sulfate-containing amino acids were suggested to be as an efficient gelation improver, and even could be potentially used in other protein substrates. That's all. Thank you.
Thank you, Dr. Zhao, for your overview of HHP and the texture and structure of sweet potato protein.